Alright, we're going to get through this page pretty quick. There's a lot of writing. Please write what I write. There will be some points where we kind of hit that little ditto mark and say, hey, it's the same as the last one, because there's a lot of correspondence between some of these logs. But I am going to talk about the basic graph of a log. Please know, right, this log right here is the common log, and it is literally this. When you don't see a base, it is assumed that that's log base 10. That's what it's assumed. So remember, when you're doing logarithms, you're really solving for the exponent. So this number is 1/10. So log base 10 of 1/10, if I plug that into that x. This really says, what power of 10 gives you 1 over 10? Well, that's a -1, because all I got to do is flip it over. This one says, let me write it. This one says, what power of 10 gives you 1? What power of 10 gives you 1? Well, that's the 0th power. This next one says, you know what? What power of 10 gives you 10? Well, 10 to the 1st power gives you 10. And if we plot those, we're going to see something that, if you remember the exponential function, this function is literally a reflection over y equals x, right? And let's do this next one. I'm going to write natural log a little different this time, just so you can see what it really is. I think it's important to look at what you're working with. And the natural log of x is really just log base e. That's what it is. They don't write it that way, but that's what the natural log of x is. So this one says log base e, 1 over e. If I plug this into that x right there, it really just says what power of e is 1 over e. Well, that once again is -1. Anything that says what power, we'll write that one again. Log base e of 0. What power of e is 0? I'm sorry, I should have plugged the 1 in there. I was thinking about the answer. Plug that right there. What power of e is 1? That's the 0. What power of e is e? 1. What power of e is e squared? Well, that's the 2nd power. There it is. It's e squared. And if we plot this guy, let's take a look. Something about -1, right? I got 1, 0. I got like 2.721-ish. And about 7.392-ish. My son's downstairs. He just did an evil laugh. Cracks me up. I think he's playing some online video game and he won, so he has an evil laugh. I think we need to talk to him about that kind of stuff, but it kind of cracks me up. I'm going back to math. Alright. So, as we can see, all of these graphs are the same, right? They really are. This graph is a little more severe because it's talking about exponents of 10, a base of 10. This one happens a little less severe. And you know what? If I had a power of 2, if I had a base of 2, it would be less severe. So really they're the same thing. Our domains always stop at 0, and they go on to infinity. So I'm going to write this. The domain of x is greater than 0. Never. It doesn't matter the base. Log base e is the same thing, right? The domain of x is greater than 0. Please write this. Your brains are going, oh man, I don't want to write this. It doesn't take too long. I'm not going to make you write all this, right? The range, both of them go down and up to infinity. This just happens to be a less severe change. So we'll say y negative infinity is less than y, which is less than infinity. Do it one more time. Y negative infinity is less than y, which is less than infinity. So that takes care of our range. The end behaviors. Look, as x goes to infinity, y is going up. It's going up to infinity. As x goes to 0, and it never goes past 0, ever. So let's write that. And, well, I'll leave out the, well, we'll put as x goes to infinity, y goes to infinity. It's always going up. As x goes to 0, and it stops there, right? Y, notice they're putting f of x over here. I'm doing y, but no, they're both things, right? Negative infinity. We'll do f of x over here. As x goes to infinity, the output of x, right, goes to infinity. As x goes to negative infinity, oh, I did negative infinity instead of 0. We can see that that doesn't go past 0. The output of x goes to negative infinity. Notice there's no vertical asymptote, horizontal asymptotes, but there is a vertical asymptote right there and there. That's what that says, vertical asymptote at x0. None. So we're just going to write same and same. I'm not going to make you write all that sentence. It increases throughout. It says intervals where it's increasing. It never decreases if you're going left to right. So I'm just going to say same. Doesn't matter the base. It's going to happen the same no matter what. X-intercepts. No Y-intercepts. Look, my X-intercept here is 1. So is this one. So let's just write X-intercept at 1, 0. X-intercept at 1, 0. And no Y-intercepts. No Y-intercepts. When is it positive? Well, it's positive when it's above the x-axis. So it's positive from 1 to infinity. It's positive from 1 to infinity. It's negative from 0 to 1. That's it. It's negative from 0 to 1. Look, it's only negative between here and here. Alright, talking about the outputs there. That's it for now. And I will see you soon with page 2.